Hey everyone, thank you so much for connecting me this morning. I know there was a lot of LinkedIn connections coming through, so obviously a lot of folks are tuning into Cube Crash, so this is great. I'm here, I'm Rob Koch. I'm based here in Seattle, Washington. I'm presenting here with this um, topic in London, but thought we might be able to get a little bit deeper in it live. However, I think we're cut a little short due to some of the things that we were working through this morning. So let me know how much time I have left. If we're running close, like hosts, definitely jump in if I'm gonna go over. So just give me a hint. So today I'm going to talk about the machine learning pipeline and implementation of Kubeflow. You might have heard of Kubeflow. It's graduating soon, hopefully. So that's some good news there. In Atlanta KubeCon, we might see that happen. So we are here to talk about. Let me just adjust my window. Give me a second here. Make sure I'm presenting there. Okay, so seeing then with Kubeflow, streamlining machine learning as well as improving the efficiency and working with the model deployments. So who am I? I am an American Sign Language user. I'm deaf. I can voice for myself a little bit passively, but I prefer to use my first language, which is sign language. It's more comfortable for me. It's easier for me to interact with people, networking wise, and in these type of KubeCon conferences. And when I'm going out and networking, it's easier for me to use sign language with an interpreter next to me. That way, I can have easier interactions, and instead of having to look up and down and taking notes and things like that. I prefer to be able to look people in the eye and communicate that way. So this is why I prefer using sign language. So a little bit about me. Um, I am fully vested in an interest in this project because I wanted to see, with my computer, I wanted to see if it could understand my signing. When I speak to my computer, it doesn't necessarily understand me, like Google or Siri or any of those. It doesn't understand what I say, and so I was trying to figure out a way to experiment or have different projects and research that's going on out there, being able to explore computer recognition. Because it doesn't recognize what we call a deaf voice, and so in this way, I thought sign's always better. So let's figure out how to get the computer to recognize my sign language. So with this, there's a few other companies out there that are making really great strides in this. There's a lot of hard work going into it, and I'll explain why sign language has its own nuances and variations regionally, and also communication styles are different, grammar is different. Some people's grammar is verb noun, some is noun verb, etc. So there's a lot of different encryption where it's like, car red or red car, and so those descriptions there and the grammar can be different within the various sign language communities. Also, it's important to understand that sign language in and of itself is spatial, right? So a lot of movement that happens with that, and describing a concept not only for translating word for word directly, it's not doing that. It's more conceptual, where there might be some sort of a semblance of a word there, or some sort of uh, gesture that represents a sign. And so there's a lot of space around us. For example, anything in the future, when we're explaining things in the future, it happens in front of us, whereas the past, it happens behind us. And where current is, like if we're talking about current day, it's happening here in front of us, right in front of our space. So there's a lot of training involved. There's a lot more data than with verbal communication. Verbal, you have audio, which is like, let's say, downloading an audio file, and then, versus downloading a video file, right? So if you're comparing the two, which is bigger? Obviously, we know that the video is by far much larger. And so with that, there's a lot more data to look into. A picture's worth 1,000 words. This is accurate, right? But in sign language, a picture's worth 1 million words, right? So there's a lot, that in the deaf community who support that idea, right? So because of that, there's a lot of data and there's a lot of things that are being brought in from the different points. With audio, you're only, hearing things. There's some variation there with accents or particular vernacular or variation in the voice. With a video of a deaf person, we've got our clothing, what we're wearing, what if I'm wearing like white or black, depending on the dark colors, the background behind me, what that looks like, how the machine learning can capture the various figures and the different facial expressions that might pop up, and whether there's good light or bad light. There's a lot of variations that can be in the video when it comes to training the model for sign language. And then, of course, we have the development time, which obviously has exponential costs involved with machine learning plus the LLMs. Um, Learning those, we learned that there are some limitations, and LLMs are a little slow when it comes to that sort of processing. So we need to improve over time, and we will. But there are companies out there that, like I was talking about before, have made great strides as far as coming up with innovative ways to speed up models and development and deployment of those and the recognition as well. So here you see I'm signing the letter K, and we were using machine learning libraries for detection of the fingers to recognize the various points within the fingers. It's pretty heavy lifting because if I were to use, let's say, all of these fingers, right, it has a tough time doing the recognition. But if I were to add the attributes to them or the properties, like the various points of the X, Y, and Z axis to the fingers, you can see these dots that are here on with the lines that shape the hand. And so that's what the machine learning model is looking at. It doesn't look at the particular what my fingers are doing per se, but it's looking at the lines of the fingers at different points. And we were training on that data. So I wanted to start this going forward from that way to capture the various points of the fingers. And so end to end, the workflow management, I know that it wasn't super exciting. We've got the boring stuff and we've got the various nitty gritty of the tech, as far as those things go. The platform we were using was Kubeflow, end to end, machine learning, workflow management, all the way through. And so having one standard platform, we could reproduce the experimentation with the deployment of different experiments and in different environments, and whether it was mobile or whether it was a website or an API, we could deploy to different places. We wanted to be able to have versioning involved. With the versioning, we were deploying the model and then we could see, maybe something that worked before but wasn't working now. So being able to revert back to some of those nuances of the model, being able to redeploy that and figure out why it was broken or something happened in the midst of things, adding a parameter that maybe broke something, let's say, different things. I'm trying to think of an example we had with the X, Y, and Z axis here with the rotation of the hand. The problem with that was the XY might be fine here. It was more than enough of our situations, but the Z would come into play later because the Z axis was the spatial part of it, right? So that needed to come into play a little bit later. But with finger spelling, it would recognize X and Y just fine. But with the Z, we had a little bit of things breaking here and there because we were trying to train the model with the Z axis. So just making sure that we were checking off those things and that they were accounted for. So in this project, it was actively being developed here and there, little by little. There were three of us working on this project. and on and off, kind of balancing our work of our clients and then also working on this project, right? We have our home life, we have our families and everything else. So being able to work here and there on the side, weekends, evenings, an hour or two, 30 minutes here and there. It was a little bit slow iteration. It was an open source project, right? So we all understand what comes into that, right? So reusing some of the things that were out there in the community already existing, no proprietary information, et cetera, et cetera. So getting into sort of the key aspects of the process of developing this project. So now how does sign language recognition work, right? So we're using computer vision model and we are using the video capturing and pre-processing. So with the finger spelling like HOW, how, the letter HOW like this, it would have to take from the video and split that out, right, to the various images within the video. So videos typically have 28 to 60 frames per second, depending on the speed of the video and how it's captured, and recognizing where am I with the particular finger spelling words and letters, right? So being able to notice that we had a lot of noise with the finger spelling. For example, if I would spell HOW, the as I transition from the H to the O, it would look like this, which would capture a C in the middle. And I never would have recognized myself as a person watching somebody do that, but the computer was able to pick it up. And so we were um, trying to figure out how to deal with all the noise and how to eliminate that C, aka the noise. We say ignore that part and then get to the O, etc. And so the time in between, was milliseconds, and so trying to figure out maybe using like a dictionary, let's say. So we were having to deal with ASL, American Sign Language. We also have BSL, British Sign Language. That's what they use in the UK. French Sign Language, of course. And so there's a lot of languages in America where, like American Sign Language, we sign G like this, but others sign it G like this, and it's a slight variance. And so there's a lot of different things where we were facing challenges with trying to build the model. And of course, the number of deaf people who were, around the world and the number of signers, not necessarily taking off in numbers compared to the number of hearing people, right? 99% of the world is hearing. And so that was quite astonishing. There's, a lot of data readily available for hearing, speech, and things like that, but not necessarily for signed languages. So now with AI coming into the picture, definitely helped speed up our process. We were able to preserve from spelling the HCOW. We would say, hey, you misspelled that. And you type it into AI and give it a prompt saying that that's not working, ignore that. And then it would say, what do you mean? Right. So providing great context within that using AI was great because the timing of this coming into the picture while I was working on the project was fantastic. And AI was able to, I was able to teach it a little bit of the sign language of what I wanted. And so the challenge of how to recognize the particular signed languages and determination of what we wanted based on context or not. So the models were using a little bit of the right. Remember, I showed that image before of tracking the fingers. We were using an open source library called Labs that was able to capture some of the extra work of what we needed it to look at from the front, the back, and the side. So if you had something like, let's say, a camera on, like maybe on your glasses, let's say if there was a camera there, how would it know when I'm signing if I'm signing at it and it's looking this way versus from behind or from the side or from the front, right? So it needs to have this um, variable spatial access, which was a huge challenge. And someday maybe you'll be able to capture a deaf person signing, across the room and be able to use the camera in that way. So we'll see how that goes. So coming back to Kubeflow, It was really, really, I mean, I appreciate all the great work. It made it really easy for us to set up the integration points across our architecture and be able to transition between the data processing as well as the training as well as the deployments. So Kubeflow, in and of itself, was part of the Kubernetes ecosystem and the CNCF ecosystem, which was fantastic. So being able to help with the facilitation of data and handling and preparation, as well as having the repeatable process and being able to add a word or a sign into that particular process, then it would be able to just keep adding more and more data and more context, uh, more and more side views, etc., to help with the whole process of the workflow, making the process much more feasible. Wanting to automate as much as possible, of course, right? And then in and of itself, Kubeflow could also automate and manage the training pipelines. And so being able to account for the various models and not having too much repetition, but also making the model size smaller and also being able to figure out the repeatability using the data, let's say like the letter A, E, we could add those things in and optimize for those quickly to be able to retrieve faster. There was also, with the last thing with Kubeflow, the scalability, being able to have that on top of Kubernetes to be able to scale up or down smoothly and to have those smooth transitions from the training to production. We were able to leverage that, adding in a new GPU or CPU. If there was a new release, we were able to add that in to the ecosystem and within our platform. So we could do this hot swap and be able to make the model quicker, smaller, more efficient, being able to tweak those resources based on demand. This was our architecture to show you kind of the data, and I understand it is small, but there's a lot going on with Kubeflow, so just wanted to represent that here. So we've got the pipeline orchestration as well that's being passed and taking our video processing piece of things, which is this section over here. So the X, Y, and Z axes, and then being able to use shift and scale within that to be able to get more of the picture or more of the details that it needed. We also had some vector storage for this portion here, and then moving over to checking against the model to compare and to see, making the inference decision from the vector to the model, being able to compare those things. And then we were looking into using notebooks on Kubeflow. And so we could have the code coming in, being able to see what exactly the model was picking up and where maybe we would have to make some adjustments, and then maybe adding some more things that we realized we needed more data for the model to work more effectively, things like along those lines. So debugging in a sense through that process as well. Kubeflow provided all of that end to end for us in the workflow management, which was fantastic. And then we had being able to using the built-in telemetry, OTel or anything along those lines that we could use along the way to check the resource utilization. Maybe things were over provisioned, under provisioned, things like that. We could check the and use that monitoring to help us out. And then some A/B testing as well, being able to test things here and there as far as the translation approach or the different model versioning. We could test a lot of those things to make sure if it was working. Some worked, some didn't. And then, of course, if you're running things in real time, being able to set up the development of the telemetry where we could, have little by little improvements here and there of the model. So here we've got some different points that I just wanted to make. The efficiency increase, using Kubeflow for various features. They're adding more and more things all the time. So it's been really great work. So I just want to shout out to the Kubeflow team. It's, there's always room for improvement, but they have been honestly improving a lot, performance enhancements, and um, seeing the successes from that has been really helpful. So now I can show you, load this real quick. So something that I had done for KubeCon London, you can see how the fingers are being tracked here from that image that I showed you before. So it's identifying the X, Y, and Z axis here and was able to pick up what I was spelling. If I did this myself, finger spelling it, as I would normally, it would not catch everything. But as I did it slow enough for the video, it could catch what it needed to. If I did just this casual, finger spelling, I had to put more emphasis on what I was signing, be more deliberate about it, so that what if we can make improvements on that space, it might be able to catch those nuances. But I really enjoyed working on this project. It was super fun. It was really cool to see it work. So I talked a little bit about this with the the story behind how we came up with the approach and the struggles that we did face, and then getting through those challenges. With the finger spelling, right, we've got, the A being back here, maybe smaller. It might have the points more bunched up that it couldn't recognize. So then when we tried the scaling option, you could see the fingers a little bit better, which was great. And then also we had tried the scale and it was working, but then the picture was too big, right? Because it was like involving my face. We didn't want that necessarily. We're just wanting the hand. But some people in the deaf world, obviously we want to see our face when we're chatting normally. But for this, we wanted to see just the hand for the finger spelling. So we would do the wraparound of the fingers here, not adding extra information, right? Because the model doesn't need all of that extra information for this purpose. So if we're asking a question here, something like that, you tend to change your eyebrows and raise them up when you're asking a question, something like that. So that information is helpful for context, but we didn't need that all for this particular purpose that we were using. We, honestly, in sign language, we need the whole upper body, including the face and the hands, to make things clear with the grammar and how everything is structured. But we were taking different approaches here just to focus on the hand. And it's not accounting for something that was like somebody who maybe lost a finger, had an industry accident, let's say, and how would we know, how would we recognize the person with that happening, or somebody who's maybe like a construction worker who might have bigger hands, or if the background was matching, whether or not you had something behind, like a white background with a, different skin tones, might have a harder time picking up the particular shape of the hands in that scenario. So machine learning with sign language is hard. I will just say that. And so our
So
approach to, yep.
I want to jump in. This is an amazing presentation, and there's so much that we can gain from it. But I do need to cut you off, Rob. It's been amazing
That's
to have
fine.
you here.
Yeah, that's great. Thank you so much. I did, do I have any time left?
How many more slides do you have?
Let's see. I think I could go real quickly through the last bit of here. One more story, and then the rest will go quick.
Okay, great.
Perfect. Thank you. So yeah, lessons learned from this particular slide. This was kind of important. This was the most crucial part of things, because with this, the model here was built by, hearing folks out there, and like Hugging Face and various places that we were pulling in the models from, which was great for having that context and the data that was coming in. However, it didn't recognize some of the letters, and we were struggling with that, and we were trying to figure out why we couldn't recognize those. And my team and I were discussing these things, and then we realized, oh, right. So some of the letters are like P, for example, P, like this. This is how we sign P and Q. The model didn't pick up P's and Q's. It didn't know the difference between the two. Their models were successful for the other letters, but we were trying to figure out, why is mine failing from this camera angle? And I realized, because when we sign P, we sign it this way, but when they trained the model, they were basing that on the images that you see here. So if you look at the P, it's like this. Do I sign P like this sideways to you? No. So it wasn't recognizing. I would never do P or Q like this. I do P and Q out in front of me. And so that's where we realized really quickly that the authenticity of the patterns that you use for, you need to really involve deaf and hard of hearing people. That has to be absolutely critical. You need to involve them in the process, because they can teach you something. They can identify these gaps that are happening. Let them lead the project. Let them be involved. This is our community. It's really important that authenticity is happening in your projects. If there isn't authenticity, you will not have any trust from the deaf and hard of hearing community. So print to reality, obviously, as explained here, is very different. So I wanted to emphasize the importance of including deaf and hard of hearing individuals and varying thoughts and varying perspectives, and also, just people that are different, right? A diverse group that can be involved in the project. So that's number one. So thank you for letting me tell the story about this part, because I think it was really important to part of working through here. So again, future things, we'll skip a little bit of this, but
Because I
essentially
do
what
have
you're.
to jump in and cut you off. Unfortunately, we have run out of time, Rob. It's been a pleasure to have you here. Thank you so much. And please stick around. If you have any questions for Rob, he'll be in the chat and can answer those questions for you.